Welcome back, calculus scholars. In this second video, we are going to talk about why we go through the exercise of taking the antiderivative. And we are going to get straight to the fundamental theorem of calculus, which is really why you even want to take a calculus course to begin with. So, what the fundamental theorem of calculus effectively does is, let's say that you have a curvy thing that you are taking the area under the curve of. This is the what we would have done with Riemann sums previous day. But to kind of get that ideal Riemann sum, you want to make the rectangles extremely narrow. It's kind of impossible task to do with this pen, but fortunately we don't have to do that because we're going to be seeing the connection very shortly with this notion of antiderivative. So we'll call this A, we'll call this B, and we'll just color it in. So we're getting the area under the curve. So what this is saying is that the integral from A to B of lowercase f of x is equal to capital F of B minus capital F of A. So capital F means antiderivative. With B plugged in. And capital F of A, well, capital F is still the antiderivative. But you're going to plug in A. And when you subtract those two numbers, after plugging in what we get for B and what we get for A, plugging in, then it gives us the exact area under the curve. As if we were to do a Riemann sum with an infinite number of rectangles that we added up. So the integral at the end of the day really is kind of like a summation. So some of you may have seen like this notation before. This just means, kind of add continuously. Another good way to kind of think about the fundamental theorem of calculus is just as addition is to subtraction. So if I were to ask somebody what is the opposite of addition, you'd say subtraction. The antiderivative is related to the derivative. So they're inverses of each other. Now, the good news is that if you know how to do an indefinite integral, like the ones that we did in the first video, you can do almost any definite integral because for the most part, you are going to be able to do the antiderivative first, and then it just kind of invites you to substitute in the upper and lower limits of integration. So we're just going to kind of show one of these just so we can kind of see the over and beyond the indefinite integral. So what's nice about definite integrals is we don't even need the graph. So if we have the function, we can get the exact area under the curve. And no need to draw out the graph or go to a graphing calculator. So we'll do the antiderivative here. 2 times 1 is equal to 2. And then I have x cubed. So yeah, that's 1/3. and we are evaluating it from 2 to negative 1. Now, technically speaking, there's a plus c, but what happens is that when you are subtracting these expressions, you're going to get a number because the plus c's are going to cancel. We'll leave plus c in so you can see firsthand how they cancel. So the first group, I'm plugging in a 2. So I get 2 squared minus 1/3 times 2 cubed plus c. And then I have a minus a negative 1 squared minus 1/3 times negative 1 cubed plus c. Now, if you're kind of somebody who finds that this looks a little bit disorganized and maybe it's hard to keep track of the parentheses, I always advise students, maybe if you're one of those type of people, just focus on one parentheses group at a time and getting the right answer for that. So maybe you want to work out this and get some number, and then maybe you want to work out this and get some number plus c as well. So that way you're really just subtracting 2 numbers. So this can kind of make you immune from those famous sign mistakes that people make. But for now, we'll just kind of evaluate this together. So in this first group, I have 4 minus 8/3 plus c. Negative 1 squared. Be careful with your calculator. Remember that the square of a negative number is positive. And then I have a negative times a negative. Negative 1 to the cubed is negative. So that's going to be a positive 1/3 plus c. Now the c's go away. So we're left with 4 minus 8/3 minus 1 plus 1/3. So this gets us to almost the final answer. Actually, I just caught something here. One of the most common mistakes that people make is the forgetting of the distribution of the sign. So we're actually going to make this a negative 1/3. And then we just combine. So I got 3, and then minus 8/3 minus 1/3 is minus 9/3. So it's 3 minus 3. And that's going to get us perfectly at 0. Love it when things work out that elegantly. So on the homework, there may be a few problems that involve those more interesting antiderivatives that you kind of have to clean up first. Something like number 4, where you're going to be putting in those limits of integration. But I would say that those are very doable if you have a good calculator. And you get most of the points, and you're showing me that you kind of understand this concept really well, even if you get to about this stage. So this is like where all the calculus is. And then now we're just kind of like cleaning up the answers to get to that elegant answer at the end where we get a number. So thank you very much. And thanks for listening in. Hope you are having a relaxing and healthy week.